Morning students, today our topic is moment of inertia. You know well the torque and angular momentum before topic. Finally, the moment of inertia is equal to mr square. Moment of inertia is nothing but is a basic equations. I is equal to mr square. This is a moment of inertia. So unit of moment of inertia is equal to kilogram meter square. Kilogram meter square. In translational motion, mass is measure of inertia, but rotational motion, moment of inertia is measured rotational inertia. That's the basics. And next one, mass is invariable in translation motion, but in rotational motion, moment of inertia is not a invariable. It is a variable, and is also depends upon the point mass distributed through the uniformly distributed through the axis where the point mass is placed. It is a very important one. And next one, in general formula, point mass. If just consider one point mass mi, position is ri. Position is ri from the axis. So the moment of inertia I is equal to mi ri square. This is a general formula for point masses. And is also overall the bulk material. Calculate the moment of inertia of bulk material. The moment of inertia is equal to summation of mi ri square. This is point mass moment of inertia. This is the overall bulk material. Moment of inertia is equal to summation of mi ri square. This is a basic formula for moment of inertia. To find the moment of inertia in a general formula, for consider a small mass dm. If the small mass position is x or r, the moment of inertia di is equal to integral of, and so di is equal to dm r square or x square. If di is equal to dm x square. If the point mass, the small mass m, the position is x from the axis, the moment of inertia of the small mass in distance of dx, the moment of inertia di is equal to dm x square. So integral overall moment of inertia, just we take an integral di is equal to integral of dm x square. I is equal to integral of dm x square or dm r square. This is a general formula for all material. For example, rod and ring is also. So the moment of inertia I is equal to integral of dm x square. It's a common formula, basic formula for moment of inertia. Moment of inertia of uniform rod. If consider, I want to calculate the moment of inertia of uniform rod. The point mass is distributed uniformly through the moment of inertia in the uniform rod. The overall mass is m. The length of the rod is L. So I want to take in a small mass quantity in distance of dx. This is small mass. This is dm and the distance of dx. In distance of dx, the quantity of mass is dm. The overall mass is m. The length of the rod is L. This I want to take the axis in of center of point perpendicular to the rod. The overall length is L, so this is L divided by 2. This is also L divided by 2. The axis placed in center of mass of the uniform rod. So mainly it is perpendicular to the rod in point of center point O. This is the main one, and I want to calculate the moment of inertia of uniform rod. Moment of inertia of uniform rod from axis. The point mass, the dm small mass, consider distance of x. Distance of x. You know well the general formula of moment of inertia di is equal to dm x square. dm x square. or integral of di is equal to integral of dm x square. I want to calculate the full rod, moment of inertia in full rod length L and overall mass is m. Just I want to take the integral value. So integral of di is equal to integral of dm x square. Integral of dm x square. Another one, what is the limit value? I mean the center of mass, which means that this is axis. AB is the axis of rod. What is the limit? I want to calculate the overall moment of inertia from limit L by 2 to this is L by 2. I want to consider this is x axis, this is x dash axis. So x dash axis is a negative value, x axis is a positive value. So the limit should be take minus L divided by 2 plus L by 2. I mean the overall L by 2 plus L by 2 goes to L. That's why I is equal to, this is a limit dm x square. Dm is a small mass in distance of dx. I want to calculate this overall mass. So here is a main concept one, linear mass density. Linear mass density. What do you mean by linear mass density? Linear mass density is nothing but is a mass per unit length is called as a linear mass density. So linear mass density which is equal to mass divided by unit length. Lambda is nothing but this is a linear mass density which is equal to mass per unit length. So lambda is equal to m divided by l. This is a linear mass density constant for the uniform rod. But I want to take the linear mass density in distance of dx in a small mass dm. Linear density, mass density which is equal to dm divided by small distance is dx. So dm is equal to lambda into dx. So dm is equal to, what is the lambda value? Mass divided by length. So mass divided by length into dx. This is a dm value. So substitute dm value is, so I is equal to integral of limit minus L divided by 2 to positive L by 2. So dm is equal to mass by length into dx into x square. So we get final value is equal to moment of inertia of uniform rod I is equal to mass by length is a constant. So limit minus L divided by 2 to positive L by 2 into x square into dx. So moment of inertia I is equal to mass divided by length. So integral of x square into dx, you know well, x cube divided by 3. So integral of x square into dx is equal to x cube divided by 3 limit minus L divided by 2 to positive L by 2. This is a lower limit, this is upper limit. You know well. So I is equal to mass divided by length into, what is the x value? X value is L by 2. So substitute is L divided by 2 whole cube divided by 3. This is upper limit. And minus of lower limit. X value is minus L divided by 2 whole cube divided by 3. This is lower limit. So moment of inertia I is equal to m divided by L into L by 2 whole cube. So L cube divided by 2 cube 8 whole divided by 3 minus of L by 2 whole cube. If square means this is positive, so cube is, that's why it's a negative, minus L by 2 whole cube. So L cube divided by 2 cube is 8 whole divided by 3. So I is equal to m divided by L into L cube divided by 8 into 3. So L cube divided by 24 minus into minus, so plus, this is L cube divided by 8 into 3, 24. So I is equal to m divided by L into L cube by 24 plus L cube divided by 24 is equal to 2L cube divided by 24. So 2 cancel, this is 12, here L cube cancel square. So finally we get the moment of inertia I is equal to m L square divided by 12. M L square divided by 12. I is equal to 1 by 12 m L square. This is a moment of inertia of uniform rod. Moment of inertia uniform rod. And there's also a main concept one. If axis is changed, the moment of inertia of uniform rod is also changed. And the moment of inertia is in a translational motion, mass is invariable. But in the rotational motion, moment of is variable. Not only depends on mass, it is also depends on the point mass distributed in uniform rotation of the axis also, and as mainly depends on where the axes are placed in uniform rod is also dependent. That's why I is equal to 1 divided by 12 ml square in a uniform rod. Moment of inertia of a uniform rod. If axis is divided, which means the axis is placed in center of mass. If center of mass, moment of inertia, axis placed in center of mass, moment of inertia in uniform rod, I is equal to 1 divided by 12 ml square. And next one example, find the moment of inertia of uniform rod about an axis which is perpendicular to the rod and touch the any one of the end of the rod. If the axis placed in end of the rod, before topic we have the axis placed in center of the mass, is placed in center point of the uniform rod. Now we are take the rod touches any one of end of the rod, which means this is a uniform rod. The mass of uniform rod is m. The length of the rod is l. You know well. If consider I want to take in a small mass in distance of this is dm, distance of dx, but the axis is placed. It is a very important one about an axis which is perpendicular to the rod. Perpendicular to the rod. It's not parallel. Perpendicular to the rod and touch the any one of the end of the rod, which means here any one of the end of the rod. This is axis AB. Now we will take limit is equal to overall length means 0 to L. Limit is 0 to L. The distance is x from axis. The point mass considered distance of small mass dm and distance of dx. The position vector, which means the point mass is placed in distance dx, mass dm. From the axis distance is x. You know well the moment of inertia formula. I is equal to, di is equal to dm x square. Dm x square. Integral of di is equal to, I is equal to integral of dm x square. So I is equal to integral of, you know well, limit 0 to L. Now the axis is placed in any one of the end of the rod. So the limit is, the overall length of the rod is L. So 0 to L, limit is equal to 0 to L and dm x square. So I is equal to integral of 0 to L. dm is equal to, what is the dm? Small mass. The small linear mass density is equal to dm divided by dx. So dm is equal to lambda into dx. So dm is equal to, what is the lambda is equal to mass divided by length. Mass divided by unit length. So dm divided by dx. So substitute dm value is equal to m divided by L into dx into x square. Into x square. The moment of inertia is I is equal to limit 0 to L. Limit 0 to L. I mean the mass m divided by L will take it outside from the integral value in x square into dx. X square into dx. So moment of inertia I is equal to m divided by L integral of 0 to L x square dx. So x square dx is the integral value is x cube divided by 3 in limit 0 to L. 0 to L. So moment of inertia I is equal to m divided by L. X value is L. So L cube divided by 3 minus 0 divided by 3. So the value is 0. So I is equal to m divided by L. So L cube divided by 3. Here L value, the cube value gets square. So I is equal to m L square divided by 3. This is the moment of inertia of uniform rod. If the axis is a very important. If the axis is touch any one of the end of the rod perpendicular to the rod, if the moment of inertia is changed, so I is equal to m L square divided by 3. If axis is placed in center, moment of inertia I is equal to m L square divided by 12. If the axis change, any touch any one of the rod, the moment of inertia I is equal to m L square divided by 3. And next one is a uniform rod of mass m and length L makes a constant angle theta with an axis. With an axis, the rod should make an angle with a theta of rotation which passes through one end of the rod, and is also the axis pass through the one end of the rod. It's not a center point. Find the moment of inertia about this axis. Find the moment of inertia about the axis. What is this diagram? The uniform rod of mass m and length L makes a constant angle theta with an axis of rotation which passes through the one end of the rod. Consider this is axis, this is rod, uniform rod. To make an angle of axis is theta. To make an angle of axis theta, if consider the small mass is dm in distance of dx. From the axis, the distance is x. In this point is r. This distance is r. Distance is r. Now, what is the moment of inertia about this axis? You know where the general formula of moment of inertia di is equal to dm r square. Dm r square. So I is equal to integral of dm r square. So just see, I want to calculate this r value. You take just triangle, this triangle, sin theta is equal to r by x. R by x. So hypotenuse, opposite side divided by hypotenuse. This is opposite side, this is an angle 90 degrees. So r, this is x. Sin theta is equal to r by x. R is equal to x sin theta. R is equal to x sin theta. So di is equal to dm r square. I is equal to integral of dm r square. I is equal to integral of dm. What is r value? R is equal to x sin theta. X sin theta. X sin theta whole square. Now I want to take limit value. So overall length, the length of the rod is L. The mass of overall mass of rod is m. As usual, you know well, limit 0 to L. Limit 0 to L. Overall length. So because of the axis placed in one end of the rod. So I is equal to dm value. What is dm value? Lambda is equal to dm divided by dx. So dm is equal to lambda into dx. So dm is equal to m divided by L into dx. You know well as is. The substitute value dm is equal to m divided by L into dx into x sin theta whole square. So x square sin square theta. And limit value is 0 to L. Remaining value, substitute this. I is equal to m divided by L sin square theta. Sin square theta in the integral of 0 to L into x square dx. X square dx. So I is equal to ml sin square theta into integral of x square dx is equal to x cube divided by 3 in limit 0 to L. So I is equal to m divided by L sin square theta. In substitute the value upper limit L cube divided by 3 in lower limit value is 0. So I is equal to m by L sin square theta. So L cube divided by 3. Here L value cancel square. So I is equal to m L square divided by 3 into sin square theta. This is a moment of inertia in this position. If the rod is to make an angle, the rod is made to the angle of theta with the axis, the moment of inertia is changed. Formula is I is equal to ml square by 3 sin square theta. Next one, find the moment of inertia of axis A dash and axis B dash. So, a general example question. See, A dash mass is placed point mass m in distance b, another one point mass is 2m, distance b, point mass m, in axis b dash, another one point mass, same distance b, point mass 3m. Find the moment of inertia of axis A dash and B dash. The moment of inertia of an axis A dash in system. You know well the general formula moment of inertia I is equal to summation of mi r I square. Summation of mi r I square. So I want to calculate the moment of inertia in axis of A dash. Moment of inertia of an axis of A dash is equal to summation of mi r I square. So is equal to I is equal to I A dash axis equal to summation of mi r I square. The overall point mass. First point mass is m, but the r value is 0. The axis placed on the point mass, so r value is 0. So here the first point value is 0. Plus second one, the point mass is m distance of b plus mi r square. What is the m value is 2m. What is the r value is distance of b, so b square, 2m b square. Another one is plus third one, distance of b, point mass is m, distance of from axis b plus b, so 2b whole square. Another one is plus, this is point mass is 3m. The overall distance is b plus b, so 3b whole square. So the moment of inertia of an axis of A dash is equal to 0. This is 2m b square plus m 2b square, 2b whole square, so 4b square plus this is 3m into 3b whole square, so 3m into 9b square. The moment of inertia of A dash is equal to 2m b square plus m 4m b square plus 9 into 3, 27m b square. So the moment of inertia is equal to 2m b square, 4m b square, 27m b square. 27m plus 4m, 31 plus 2m, 33m b square. This is the moment of inertia of axis of A dash. And next one is moment of inertia of an axis of B dash. Moment of inertia of an axis of B dash is equal to, what is the moment of inertia of an axis of B dash? I is equal to summation of mi r I square. In our convenience, just moment of inertia of B dash is equal to I is equal to summation of mi r I square. So B dash is equal to summation value point from this point. This is the axis B dash. From this point, m into m r square, r value is b plus b, so 2b whole square, and next one is second point mass is 2m plus mass 2m, distance b square, so distance b square, and plus third one point mass m, then axis point b dash, third point, this mass is placed on the axis, so the r value is 0, so moment of inertia is 0, plus next one is point mass 3m, distance is b square, so moment of inertia of b dash is equal to m 2b whole square, so 4b square plus 2m b square plus 0 plus 3m b square. So the moment of inertia of an axis of B dash is equal to 4m b square plus 2m b square, 6m b square plus 3m b square, so 9m b square. This is moment of inertia of axis of B dash. Thank you.